Hi there. In this demonstration, I want to show a quick technique for matching the proportions of each of your map frames. Second, making the scale and extent of all four map frames match and be dynamic and react dynamically. And finally, how to make the color schemes match. So just so that everyone's on the same page, I've got four map frames demonstrating four different resolutions. So upper left, I have LiDAR. Upper right, I have stereo. Lower left, a 10 meter DEM, and lower right, a 30 meter DEM. I've just zoomed to the full extent of each data set. The smallest set of tiles are from the LiDAR, of course. Monroe Mountain. This is the same area here on the 5 meter. And then on the 10 and 30, we're looking at this little area right here that, of course, is cut in half by the tile that we downloaded. So you can see a much bigger area and extent for the 10 and 30 meter DEMs. Okay, so we're going to use our LiDAR, the 2 meter, whatever this is. It's probably half meter LiDAR. We're going to use this as our anchor and set the other ones to match. So first I'm going to go in and look at the size. I've thrown all four map frames on my layout. It's a good size, but I'm just going to double check. So it's 4.5 by about 3.5. So I'll round that so I can use those values for all my map frames. And then for my 5 meters, same thing. I'm going to go into the properties and set the size to be 4.5 by 3.5. And then in the display options, I'm going to constrain the display by linking it to a map frame's center and scale. And then I'm just going to keep picking the LiDAR as my anchor. And so right now, it has set up the same scale and extent. It looks a little bit different because this tile is smaller. So I can zoom into this one a little bit. I don't want to do too much, but you can see this one dynamically reacted and is matching in scale and extent. So I'll just repeat that quickly for the 10 meter. First going in and setting my proportions, 4.5 by 3.5. And then going to the display options and constraining by linking the map frame center and scale to the LiDAR. So this is going to look quite different because of the color ramp, first of all, and because our data doesn't go over that far. The end of the tile is right here. So I'll have to adjust that on this map frame, but first let's set the 30 to match. Okay, now all four map frames are set to mirror what happens in the LiDAR map frame. So if I activate this one, I can pan and zoom, and all four map frames dynamically update, which is very snazzy, in my humble opinion. Okay, so next and last, we need to make sure the color ramps match. So why are they drawing the way they're drawing right now? I have the same color ramp set for all four elevation models. Remember, you always leave the hillshades black to white. The exception being if you're showing a hillshade by itself, or you know what you're doing, you can always set these white to some other dark color. It makes it look kind of cool if you go white to a really dark brown or something. It gives that kind of vintagey antique look. But color ramps themselves only go on the elevation values. Okay, so what's happening here is that from green to white, that full range of colors is displaying the full range of values for each data set. And because the 10 and 30 meter rasters are so much bigger and cover a broader area, they have a larger range of elevation values. So for example, the 30 meter data has a minimum elevation of around 1,400 and a max of 3,700. The 10 meter is going to be very similar because it covered pretty much the same area. So 1,409, 1,400 to 3,700, a little bit higher and a little bit lower. And I'm wondering if you can wrap your mind around why that might be. Why would a 30 meter elevation raster that covers the same basic area as a 10 meter elevation raster, why would the 30 meter have slightly higher minimum and a slightly lower maximum? And it's because a larger cell area is going to average. So if the average is up near a peak, you've got a bigger area on the ground, so you have more lower elevations that are going to bring that average elevation down. I don't know that that's exactly what's going on here. Maybe the extents are a little bit different, especially for the minimum, but for the maximum value, they should be the same technically. But the 30 meter is going to have a slightly lower because it's averaging over a larger area, and at a peak, you're going to have lower elevations, bringing that average down. Okay, that was a little tangent for you. All right, so the smallest extent is the LiDAR data set, and it has a range of values from 2600 to 3400. So a subset of basically these value ranges, 2600 to 3400. This is the smallest range of values. And so we're getting the full range when we look at this entire, actually I'll just do it this way, zoom to layer. So we're getting the full range from green to white here, but here we're not able to see the green colors because the green is way out, in the valley. Okay, so what we want to do is constrain the way that the other three data sets display using this smallest range of values. So let me zoom back into this area. I like this area as a comparison. All right. We can decide if we want to create a subset here. We could use the Explore tool, or Navigate tool, to sample. It's the Explore tool to sample the cell values at kind of the lower end and higher end here, and we could create a subsample. Let's do that. Okay, zoom to the layer. We'll use the Explore tool, and it was here-ish, so let's make a range of values from about 2800 to something in here. 30, let's go 28 to 3300, so a subset. Okay. So then we're going to go into the Symbology. And instead of percent clip, do our min-max and set the custom min-max. So 28 to 3300. We're getting almost the full range there. Okay, now we want to do that for the other data sets. It's basically that simple. So we'll go into the Symbology for the 5 meter data set, min-max, custom. Oh dear, oh no, I can't remember. I think that's the range we used. Yep, looks pretty similar. All right. Not percent clip, we want min-max, custom settings. Okay, and last but not least, okay, change that to min-max, custom. Okay, now we have the same display on each, and just to bring it all the way through, look at the way this ravine pretty much disappears on that stereoscopic autocorrelated DEM from the AGRC, and then comes back almost as clear, obviously without the same precision, but excellent accuracy in the 10-meter data set. And here it's completely gone. This is one of those places where if we were to sample the difference between these two elevations, we'd see huge error because the entire ravine is being masked, probably because of heavy vegetation in here. All right, that's it.